Okay, so I am someone who is aggressive. Okay, and you know what I like to tell people, which I've been saying for for many years, since the time that I have been playing Nintendo. Okay, I have said, um, you can tell a lot from a person by how they play their games. Okay, and I'm not kidding. All right, and it has a lot of validity. Okay. Now, when you're living with someone and you are understanding who that person is and starting to see a lot of faults in that person, and not because you're looking for faults, it's just because those faults are there. Okay, and the faults that I'm talking about is blaming everybody else for your problems. Okay, them making excuses on why they don't work towards their goals, or even make goals, or even make any type of structure in their lives. And you can see this while playing games with them. Okay, like, let's say World of Warcraft, for instance. Okay, and that person refuses to use the mini map and keeps asking you, as a team, a part of your team, okay, or group, it keeps asking where you are, when all you gotta do is look at the mini map and look at the arrow and look at the dot on the screen. Okay, all right, to the point where you just stop responding to that person. Okay, because after months and months and months of saying the same thing, look at the mini map. Okay, that person is never going to change or make an effort to look at the mini map, and you know this. Okay, all right, and you look at her life. Okay, and giving every opportunity that you see that person has, that person will never, ever, ever, ever make any changes in their life. And in fact, okay, they will make sure and go out of their way to do nothing, okay, all right, and blame it on, I'm afraid I'm gonna fail. No. You need to understand something. Not making a choice is making a choice. Okay? Alright, and that person lives in a fantasy world. They cannot phantom, okay, that being a process. Okay? I'd rather not make a choice instead of making the choice and fail. No. You made the choice not to make a choice. That's your failure. Okay? Alright? So things don't change by you sitting on the couch, okay, and not contributing to any type of change in your life. Alright? So, The Prince of Egypt, one of my favorite cartoons for one scene. Okay, alright, where Die Hard is Yippee-Ki-Yay at the end, and him falling off the actual tower, right? Even like in the movie Die Hard with a Vengeance, he was like, yeah, I didn't like my brother, but, there's a difference of not liking your brother and him being thrown off a 36 or a 40-story building, right? Okay, it has some truth to that, okay? So, you need to understand that with the Prince of Egypt, okay, although their magic was fake, okay, their success in creating a validity towards their power for the other people in their town, okay, believed in it. All right, that success. They had no power, okay, compared to Moses. Moses is just figuring things out, but in the end, even Pharaoh was like, okay, man, you want to go down this path? Yo, guys, show them what we're about, okay? And he just sits down and watch, because he knows that the display of their power is going to outweigh Moses' power. So, the reason why I like that cartoon is for the simple fact you're playing with the big boys now. Okay? Now, this has some validity with me climbing up the ladder as a network engineer. Okay, and sometimes you got to look and say to yourself, "Am I growing too fast?" And say, "Hold on," and put the brakes on, and let's back up for a second. Okay, maybe me being aggressive has got me to a position where I'm out of place. Okay, and if you're not going to help me grow in this position, then I'm going to take a step back and get a lower position where I can grow. Because that time spent, all right, yeah, I might be stepping back for a year, but the position I get for that year excels me way farther than I would have ever been if I would have stayed here for a year. Okay? Does that make sense? All right, so when you start playing with the big boys, start paying attention what the big boys do. Okay? Ask the questions not from a concept of what should I do, but ask the question of why do you do? Okay? So, with that being said, all right, now we're getting into the big boy territory because we are going to take a look at a routing protocol called EIGRP. EIGRP is a Cisco proprietary hybrid protocol. Now, as RIP uses a hop count to measure distance, okay, we have two different types of routing protocols. We got link state methods and distant vector. Now, distant vector is the concept of hop counts, okay, all right? But we call EIGRP a hybrid, which I don't call it that. Cisco calls it that. I just call it a routing protocol. It's the concept of, like, you know, Homer Simpson, right? When he was like in Brazil and he's like, look, you know, I have a bladder the size of a Brazil nut. And he was like, yeah, we just call them nuts here. Which would make sense because you're in Brazil. Why call them Brazil nuts? All right? Okay, we call them Brazil nuts in America because they're from Brazil, right? I said Brazil, but I meant to say Brazil. So, nonetheless, okay, the slurring of my words is just part of what you get. So, sorry about that. All right, now, you see this thing down here? Let's kind of lower this. Okay, this here is an algorithm. It's a mathematical equation. Okay, and this is how EIGRP, every time it's ran, determines the distance of a route. Okay, now when I say distance, I mean it's not a hop count, which means I have no idea how many hops it really is unless I do another command called a trace route. All right, but at the same time, this is its method of calculation. Okay, the only time I go to this method is when I am educating, and that's about as far as we go with that algorithm, because the algorithm isn't my concern. All right, having knowledge of it isn't my concern. EIGRP, RIP, OSPF, BGP, they do their thing in the background. Okay, now knowing how it works is important. Okay, so you can make the routing protocol do what you want it to do. So this algorithm down here is called a dual algorithm. All right, why it's called that, I have no idea. Now, the cool thing about EIGRP is that it stores routes. Okay, all right, that means it has a topology table. Okay, and it creates backup routes, meaning that when a link state protocol like OSPF, okay, when a link goes down, it has to run the entire protocol to readjust for the actual link going down. Or if a link is added, same thing. Okay, link state means is it up or is it down? Okay, the state of the link. Okay, all right, what's the cost value? All right, just like cost in OSP in spanning tree. Okay, what's the bandwidth value? All right, now EIGRP uses bandwidth as well, and you gotta understand something about the bandwidth. Okay, hold on. If I could just find my mouse, wow. This bandwidth has a value. Okay, now I need to make sure I'm perfectly clear on this. Alright, the bandwidth value on the interface might be 100 for 100 megabits per second, 1,000 for a gigabit, okay, alright, so on and so on, okay. Now, as far as kilobits are concerned, it's going to be a different value. But you changing the bandwidth value on an interface, okay, does not change the wire speed on that interface, okay. Now, you can change the wire speed by doing other things like quality of service, okay, all right, and lower the bandwidth, but you cannot physically change the speed it takes to put data on the wire or the speed it takes to send that data out. Okay, now, how do I cut the bandwidth in half? Well, okay, configure it so that every second, okay, of that, and I mean every second, all right, only transmit half of that second. Okay? Think about that. If I'm transmitting not the full second, but only half of that second, every second, okay, my 100 megabits per second is going to drop down to 50 megabits per second. That makes sense, right? Okay? All right, and you can do that with quality of service, which is cool as hell. Now, keep in mind, if I'm changing the bandwidth and the speed doesn't change, then what the hell is the purpose of the bandwidth? Okay, the bandwidth, okay, is used for data reporting, okay, or manipulating the routes as far as saying that this is now a 100 megabit interface, which will have a worse metric, okay, or a less desirable metric than the 1 gigabit link that's his partner. Now, you got to understand, both of those links are still 1 gig, and they're going to transmit at 1 gig. But you change the bandwidth value, making EIGRP's algorithm change the method of the metric for reporting that link as a certain number or a certain value. Okay? All right? Now, one of my projects, and I've complained about it, not complained, but mentioned it before, was changing the bandwidth on all the ISP links, okay, on 200 routers. And the reason why that was because one of the engineers thought they were getting incorrect reporting, and they were right, because out of those 200 routers, there was a lot of bandwidth commands that I had to change. Okay, and the data that they got back for whatever software or program they were using, okay, they got back all the right data now. Everything actually looked so much better in their reporting. Okay, so for whatever reason, maybe the previous engineers thought that changing the bandwidth was their way of throttling traffic, okay, to the ISP. All right, but that's why you have quality of service for that, okay? All right, changing that does not change the speed, so don't think it does. And that is a huge misconception for CCNAs or people basically getting into the field thinking that I want higher speed, so I'm just going to change the bandwidth command, okay? So now, that, just keep that in mind. All right, now, another thing about EIGRP, the whole thing about these backup routes is if it has two paths across multiple links, okay, EIGRP will do one or two things. One, if the bandwidth or the metric comes up as equal for those links, it would literally use multiple links to send that data. First packet goes down this one, second packet goes down this one, third packet goes down this one. Does that make sense? Automatically, okay? You'll literally see multiple entries. I mean the same network for multiple interfaces, which is cool. Okay, now if I have a better metric, okay, that's better than all of them, then that's what goes in a routing table, and the second best path gets stored as a backup path for that route. Now the cool thing about this is like I said, in a linked state, I have to recalculate the value every time I add a link or take away a link, so on and so on, or change the parameter of a link. That triggers the algorithm as well. But with EIGRP, I do not have to run the algorithm with that backup route, and that saves CPU processes and time. Okay, once that link goes down, the primary link with the best metric, automatically the backup route comes in, which is great. Okay, now load balancing or load sharing. Remember what I said about the two. Okay, most of the time we're load sharing, but it doesn't really matter because using the term load balance, if you argue the fact that, well, and kind of like tip your glasses, all right, and straighten them out, and say, it's literally load sharing, not load balancing. Okay, well, now you are the asshole of the group. Okay, all right, and you're splitting hairs. You know what load balancing means from the perspective of that verbal usage in that context. Okay, all right. So here's the thing about load balancing. Load balancing is the concept of sharing the load equally across links. Okay. For every packet that goes down interface 1, a packet will go down interface 2. Okay? Now, if you have packets, obviously your load balance, if you want to be technical, okay? And how can you load balance odd packets? And now you're just being a dick. Okay? You know what I'm saying? Don't be a dick. Alright? Look at the concept of what you're really doing. You're using multiple links to send the same piece of data as a whole. Okay? Now, that means, obviously, all the data that you're trying to send is higher than 1500 MTU, right? And if that's the case, if we're using 1500 bytes as a maximum transmission unit, which is MTU, that means every 1500 bytes, we have to re-encapsulate that packet or that data into a new packet every 1500 bytes. Okay? Now, you have jumbo frames where you can actually go up to 9,000, maybe even more. Okay? But nonetheless, by default, your MTU size is 1500. And you can change that on a switch if you want to. Okay? But think about what you're doing. If you make the MTU smaller, that's just more packets that you have to create, all right? And that's just more headers, and that's more bandwidth you're going to be utilizing for every piece of data that you send, okay? So now, with that being said, the cool thing about EIGRP is I don't have to have equal costs to load balance. I have load balancing, and I have a command that's called variance, which allows me to do unequal load balancing. That means that this link could be 10 megabits per second, and this one could be 100 megabits per second, and I can load share across both links. Now, if I'm in a conference call and I say, well, we're load balancing unequally across two links, okay, everybody knows what I'm talking about, okay? So don't do that with the verbiage, okay? All right? It's just... I don't know if you call it pretentious or splitting hairs. I just like the law and the rule of just not doing it. Okay? So now. Okay. Remember the Inticast and the Unicast and the broadcast traffic? Well, there's another type of traffic called multicast. And multicast is the concept of going from one source to many destinations that have been assigned itself to that particular broadcast, I should say. Think of multicast as one source sending out a TV signal, and everybody who wants to be a member of that broadcast tunes their TV to that station or that channel. Okay? You are joining the multicast group of that broadcast. Okay? That means if I send out a message to a multicast address, anybody who's joined that multicast group will get that message. Okay? If I don't want to get that message anymore, I will unjoin that multicast group. So, the big boys know that the multicast address of 225.0.0.10 is the multicast address for EIGRP. 224.0.0.9 is OSPF. Okay? Now, these are important information. Okay? Now, the cool thing about multicast is the only people that's going to receive the multicast messages are the ones who join the group, which is great. So now, alright, that means the moment I enable EIGRP on a router, it starts sending out messages to 224.0.0.10. In order for my directly connected router to get EIGRP routes is to join that group. How do I join that group? Well, enable EIGRP. And now they're speaking the same language on that particular IP address, on that multicast address. Okay? Now, EIGRP is very simple to configure compared to other routing protocols. I mean, it's very simple. Okay? Alright? Now, it does use autonomous system numbers, meaning that when we do a router EIGRP, just like we did a router RIP, after that router EIGRP, we have an autonomous system number. Okay? The cool thing about it is we can have multiple autonomous system numbers, but the only one who's going to share routes with each other are the ones who are assigned to the same EIGRP autonomous system. Okay? If I say router EIGRP 1, I got to say router EIGRP 1 on the other one, because that means they are a part of the same autonomous system. Okay? Now, passive interface. Passive interface is a way of shutting off EIGRP on a particular interface. EIGRP, which we're going to learn, okay, in the beginning, on how to turn on EIGRP for all interfaces, okay? But we're also going to learn that what passive interface is, which is what I'm telling you now. But passive interface says, for this particular interface, now keep in mind, router EIGRP configuration is for the entire router. All right, passive interface is on a interface by interface basis, meaning that I have to go into the interface and say passive interface for EIGRP 1. Okay, that shuts it off for EIGRP and that autonomous system. Okay, yes, I can have multiple EIGRP autonomous systems on a router, and yes, I can use them interchangeably. Okay, with other routers having attachments to other autonomous systems. Okay, all right. If you want to make that complicated design, it's your network. All right, be who you want to be. That's fine. Okay. Now there is a passive interface default command, which will make all the interfaces in passive mode. And you'd be like, why would you do that? You would do that because that stops any interface being a part of EIGRP that you don't want, and it makes you manually go in there into an interface and say no passive interface EIGRP autonomous system 1, and that in itself is a action that must be taken in order for EIGRP to be enabled on an interface. Cool, pretty cool, huh? Okay, that's why you would use that command, because your engineers have to take an extra step to enable EIGRP on the interface. It's just not gonna, enable all, any interface by default. Okay, now, okay, so now let's go and let's enable router EIGRP, and there's my autonomous system number. Okay, 1. Now, okay, so let's okay. Okay, alright, so let's get this up and running and take a look at our EIGRP. Oh, I think, hold on. Okay, so now, remember that network command we did in RIP? Okay, well, here she is. Enable routing on IP networks. Okay, so, if I do this, all right, let's go over to router 2. Okay, all right. Now, going back into router. I'm going to say network 0.0.0.0. And that's it. What does that 0.0.0.0 mean? Now, we know that's a default route when we're doing the IP route command. But all zeros and the network command will enable EIGRP. Okay? And now we can say show IP EIGRP1 interfaces. Wow. You got to understand what is happening here. First, I am enabling EIGRP on the loopback address and the FA00. Okay? Once that interface is enabled, the subnet of that interface, the network number, not the actual IP address, is going to be advertised and sent out those interfaces. Now, one of those interfaces is the loopback address, so it might get sent out, but it ain't going nowhere. But since FA00 is enabled, it's going to come over here to router 2. Now, an interesting thing is going to happen when I enable all the interfaces. First of all, let's do 2. Okay? Nothing happens. I'm in 2 different autonomous systems. Okay? Now, let's do 1. And look at that. This says dual. Okay, now there's 5 after here. Anytime you see like a 5, a 3, a 4, a 2, those are different levels of messages. Okay, when we get into debug commands, you'll learn that later on. Okay, now EIGRP IP version 4. Okay, not 6, but 4. Okay, neighbor 192.168.12. FA00 is up new adjacency. What the hell is an adjacency? Well, an adjacency is the concept of a neighbor adjacent to you, next to you. Hi, neighbor. Okay? Alright? You cannot have EIGRP without this adjacency relationship. That in itself is a separation from RIP right there. Okay? Because in order for EIGRP to exchange information with its neighbor, it needs to form an adjacency. Now I can say show IP EIGRP one, and I'm just going to try them all because I can't remember which one I want to see. And that's not it. So, but here is the topology. In the topology, this is where you will see backup routes and things of that nature. Now, let's go to router 2 and take a look at the routing table. Okay? Automatically, we have D routes, which are EIGRP routes. Okay? And now I'm able to ping because it's in my routing table. Okay? 1.1.1.0 via. There you go. Okay? And there we go. I'm able to ping the next network down the line of router 1. Okay? And where is my... There it is. Okay. So now, look how easy that was. I set up a routing protocol with just one command. Network 0.0.0.0. Okay? Now, let's see what happens when I do this. Come on. My adjacency goes down. Okay? Alright? So that means a lot. So let's say no passive. Oh, I'm sorry. We gotta go on the interface itself. No, this is a router command. Not an interface command. I'm sorry, I was wrong about that. There we go. Yeah, I'm so sorry about that. I gave you wrong information. Okay? Alright, this is not an interface command. This is a router process command. Alright, but it is specific to every single interface. My adjacencies are back up. Now, let's take a look at our routing table. Alright. Okay. Alright, I'm back up and running. Now, okay, I did not, oh, there it is, okay. So, technically, 1.1.1.1 should not be in the routing table, okay? But you gotta understand something. This might be because it's in the topology table and it just automatically goes back in there. I'm not sure, but I should have to do that for the loopback 0 interface as well. But until we do a lab to have multiple interfaces and test this, at this point, obviously, we don't have to do it on the loopback interface with a no passive interface command. Now, let's do section router. Okay? All right, and there is our command and our configuration, but these two are not needed, as you know. Okay? All right, now let's take a look at show IP EIGRP 1 interfaces, and we're going to take a look at FAS00 specifically, okay, or all of them. All right, and show IP EIGRP neighbors. Okay, all right, that's a very good command, showing that your neighbor is up. Show IP EIGRP 1 traffic. Okay, all right, that's good to know. Shows you your hellos are being sent. Okay, updates that are being received. All right, it's nice to see that 7 has been sent and 8 has been received. Okay, so let's do show not IP EIGRP but EIGRP protocols. Okay, all right, now. So you gotta understand, we got show EIGRP and IP EIGRP. Okay, so that happens a lot on the routers. So sometimes you got to remember this, which is most of the time coming from memory, or do question marks to see if they're there. Okay, so now the K values. Okay, by default, EIGRP enables 2 values of the K values, which is K1 and K3. And what these are parameters of the actual algorithm. So K1 is the bandwidth. Okay, that will be this part of the algorithm here. Okay? Alright? And K3 is going to be your delay. Alright? Which is right here. Okay, now, what is a delay? Here's your bandwidth of your interface, and here's your delay. Okay? That means because the K values are set to 1 for these 2 parameters, all I have to do is change the bandwidth value or the delay value of an interface, and it will change the metric of that route. Okay? Show IP route. 2.2.2.2, there's my administrative distance, which is 90. Okay? And here's my metric. So now, let's go in and say delay is 5. Do show IP route. And it did change. Okay? It took a second because look here. 160 is the last value. 156, 160. The second time we did it, it's the same, but hit it again, and now it's 5154880. Okay? Alright? That means now, if this was hooked up to another interface, okay, the other interface would be this value, and it would be considered a lower distance than this one, and all I did was change the delay of that interface. Okay? Alright, so in order for EIGRP to form adjacencies, your K values must be the same. Okay? Without the K values being exactly the same, okay, alright, it's not going to form an adjacency. Alright? It's not going to come up and you're not going to share routes. Okay? We used the default settings and did not change anything else. Now, here's the thing. I like in EIGRP to turn off the K value for the bandwidth. Okay, I like to actually only have the delay as a measurement for a metric. That's just me. Okay, but then again, all right, if there is a standard for that in your company, you got to follow the standard. So it doesn't matter what you want. Okay, all right. So now that is the introduction to EIGRP, and be strong, be determined, be Cisco.